Hello, my name is Dr. Jason Ackerson. I'm a research soil scientist at the Soil Health Institute. This talk is intended for certified crop advisors who are interested in adopting or helping their clients adopt soil health management systems. And today we'll be specifically talking about ways you can adopt precision agriculture and the tools and techniques of precision agriculture to inform soil health management or the adoption of soil health management systems. This talk is part of a larger webinar series titled Assessing Soil Health. And in our webinar series held in conjunction with the Soil Health Institute as well as the Soil Science Society of America, we've covered several topics relevant to CCAs regarding soil health. These remaining webinar series, if you're interested in them, are found on our YouTube page as well as the Soil Science Society of America CCA portal. Speaking of CCAs, if you're a CCA in need of a CEU credit, those are available for this topic as well as topics on our previous webinar series. However, you'll need to follow the URL listed on the screen to access those CEUs. I will note that the CEUs are available for free through the generous support of the Walton Family Foundation. So if you're interested in receiving a CEU for this topic, please view this recording on soils.org. And follow the links below to receive credit for that CEU. So with our introductory material out of the way, I wanted to briefly outline the topics for today's discussion. So we'll start with a brief introduction to the aspects of integrating soil health into your current CCA consulting practice. And next, we'll introduce or refresh you all on some of the principles of precision agriculture. What are the fundamental ideas around precision agriculture? And then we'll round out the discussion with sort of two case studies about ways we can apply those precision agricultural tools to soil health, specifically looking at measuring changes in soil health indicators, so using precision ag to measure or monitor changes in soil health, as well as using precision agriculture to measure or quantify changes in management that might impact soil health. So like I mentioned, our first topic will be a brief introduction to a way of thinking about integrating soil health into your existing consulting business. Think about ways that experts such as certified crop advisors can help clients understand or manage soil health. I really think about it in terms of sort of two questions. The first one being, how healthy is my soil? A client might want to know what the current status of their soil is and thinking about, is it healthy or is it not? And there are lots of ways in which CCAs can help answer these questions, and precision ag is only one of them. To the question around how healthy is my soil is kind of the natural next question, which is, well, if it's this healthy, can I improve it? Or if it's unhealthy, what are the practices I can adopt to improve it? And certainly a lot of CCAs, particularly if you're listening to this webinar, are probably interested in ways of applying or integrating soil health into their practices. So you're probably familiar with practices such as no-till or applying cover crops or introducing livestock. These are all ways you can improve soil health, but really our goal here is to provide a framework for you to have conversations with your clients about how to integrate those practices, and specifically using precision ag to quantify the impacts of those practices. So if we kind of recap these two main questions, really they do a good job of outlining the value that a CCA can provide in terms of soil health services. And that is really providing the expert guidance to answer the questions of how healthy is my soil, and also how healthy can it get, as well as how do I change my management to improve my soil's health. And that gets to sort of two aspects where precision ag and soils data can be really useful in helping inform those questions. So the first question around how healthy is my soil really gets back to the questions around measuring and monitoring soil health. What's the best way to assess the current health of the soil and understand the direction that it can go in the future? The last part of that, around how do I change my management, really gets into the questions around what are the ways we can alter a management system to improve soil health. And we'll be discussing some ways we can use precision ag to help put some numbers to those questions so that your answers are more quantitative and less fuzzy. So one of the important aspects of helping your clients answer the questions around how healthy is my soil and how healthy can it get is really having some numbers and interpretable goals around what soil health should be for any given soil. So what we're showing here is a graphic representing three different soil health measurements: total organic carbon, CO2 carbon respiration, which sort of measures the microbial activity of the soil, and then aggregate stability, which tells us, how structured or cohesive the soil is. And ideally, we want all of these values to be high for a healthy soil. And we know that if we manage soils under different conditions, we're going to see different values of these soil health indicators. So what we're looking at on this graph are values for one soil managed in three different scenarios. The orange represents a business as usual scenario, where these soils are managed, with conventional tillage, high levels of inputs, low or no cover crop usage. And on the other side of the spectrum, we have what we're referring to as a reference state. This is as undisturbed of a soil as we can get. So typically these are some sort of perennial systems. These might be native forests or restored prairies, but more often than not, these are some sort of permanent pasture or permanent grass area. And then somewhere in between, we have soil health management that tries to balance the needs of production agriculture with the conservation goals of maybe a more perennial system. And what we notice is that for each of these indicators, the values change depending on which management state you're going into. And that really gives us some teeth to apply and use to build goals when talking to clients about soil health management. So if your client comes to you and asks, how healthy is my soil? You could go out and say, measure the total organic carbon. And from that measurement, help your clients build a goal for what they need to make in terms of their targets, right? So we might identify a soil health target for a client to say, we need to enhance our soil organic carbon from less than 40% of the mean reference value to 70% of that mean reference value. So if we think about that first set of lines here regarding total organic carbon, that's really thinking about moving from areas near those orange bars under the business as usual scenario, pushing them closer towards the green bars, with our target being moving as close to the green bar as we possibly could get. So things like soil health targets really give us a way to put some numbers to those goals around managing soil health. And there's a lot of neat ways we can use precision ag to help measure and quantify those goals. So as we think about identifying and building soil health targets or goals to which we need to manage our soil health, it's also important to recognize that those goals or targets are site specific. They're dependent on the specific soil, and the environment that that soil's in can change the value that those targets can take. So what we're looking at here is another graph of soil health targets. And this time we're just looking at data for soil organic carbon. But we're looking at data from two separate sites. The upper set of lines represents data from Wisconsin, while the lower line represents data from Missouri. And again, we're showing data from three different management scenarios: our business as usual in gold, soil health management system in blue, and the reference state in green. So the important takeaway here is that when we move soils, when we move sites from Wisconsin to Missouri, the value of our targets change, which means that the goals for managing soil in Wisconsin need to be different for the goals in Missouri. And this concept scales even down to the field level. Some spots in a field are going to have higher target values than others because the soil will have a natural propensity to score higher on a particular soil health indicator. In this case, soil organic carbon. So as you move from one location to the field to the next location within a field, you may see changes in those targets, and you need to be thinking about that when measuring and evaluating the soil health in your field, as well as planning soil health management. The same way we think about managing within field variation using a site-specific approach in precision ag, we can also apply that same logic and that same thinking to evaluating soil health to site-specific targets within a field, using the same sets of tools we use for site-specific production across a whole suite of precision ag tools. So hopefully by now we've given you some context for how you might be thinking of ways to adopt your current management or consulting strategy to integrate soil health. Now we're going to sort of step back and talk a little bit about some of the precision ag principles and tools that you probably are already familiar with. And then we'll think about ways we can integrate those same tools into that soil health consulting approach. So when I think about precision agriculture, I really think about three major components. The first being precision ag data, right? Over the last 2 decades, we've seen a wealth of data products out there that help describe the variation of agronomic environments within a field. So these might be things like yield monitors or UAV or satellite imagery that all tell us how those fields vary within very short spaces. And that gives us a lot of data to start building inferences from and making management plans that can identify and address those environmental variabilities. The next piece to the greater precision ag paradigm is thinking about ways we can take those data, precision ag data around the environment, and apply them to what we'll refer to as site-specific management, or identifying ways you can address those environmental variations through intensive management to promote sustainability or profitability on a field. And that goes part and parcel with the last component of precision ag, which is data-based or data-driven decision making. We're taking this high resolution, both spatially and temporal precision ag data, applying it through site-specific management to try to make really data-driven decisions where we're changing and adapting our management to known environmental variation and known responses to that environmental variation. So it's a really data-rich environment where we're integrating all these components to make one. So given the wealth of tools that exist in precision agriculture, I think it's important to talk a little bit about which ones are commonly implemented and how they might relate to soil health management. So the data we're looking at here is collected from a survey of precision ag dealers who responded over time to a survey asking them about what services they provide. And here we're looking at the percentage of respondents who said they offer some service in that space over time. And I want you to keep in mind how these might have direct import to managing soil health, and specifically around the site-specific management of soil health targets. So if we look at the top 2 lines, the gray and the brown, those are grid or zone soil sampling. So managing the site-specific variation of soils, as well as providing some sort of spatial identification of what that field might look like. So 2 of the most highly provided precision ag services have direct import to managing soils. Other things like satellite or UAV imagery also are very highly provided. Around 70% of service providers provide some sort of satellite imagery, another really useful tool that we'll talk about in the future. The goal here is to get you familiar with the fact that there's a ton of precision ag tools already out there, and many of those that you are probably providing to clients today have direct import to managing soil health. So if there's any takeaway from this section, I really want you to think about the fact that most service providers, likely many of you listening to this talk, are already providing services that have direct import to soil health. Think about zone soil sampling or UAV imagery analysis or GPS site mapping. So all of those have direct import to the way you can manage soils for improved soil health. And you might just need to adopt those tools, often very slightly, but they just might need a little tweak to make them more helpful for soil health management. But the real takeaway I want you to think about here is we don't need to invent new precision ag tools. I'm not going to present a bunch of new software or data packages or things you need to buy or invest in. We're really going to talk about ways the existing services you provide can be altered or augmented to support soil health management. So with that really brief introduction to precision ag out of the way, we're going to talk about the first of our 2 case studies, thinking about ways we can take those existing precision ag tools to measure and monitor soil health. So before we get too into the weeds here, I really want to contrast and compare the terms measuring and monitoring because they have important implications for the data lift that goes with each of one of these and the implications of using that data. So measuring really focuses on answering the question of how healthy is my soil? At this point in time, how healthy is this soil? And really the leverage here you have is to compare that measured value at a single point in space and time to a target or a reference. This is where having those reference or target data are really helpful. The sort of equivalent you might think of in classical soil sampling or fertility management would be, do I have enough potassium in this soil? Do I need to add fertilizer? Monitoring, on the other hand, compared to measurement, takes a more long-term view. It's thinking about how those properties and how those soils change over time. So really the salient question here is my soil health improving? So you might have a client who's adopted a management practice and they want to know if it's actually changing their soil health. So to do that, you need to compare measurements of that field to previous measurements from that field. So you're coming back and revisiting a field and remeasuring it to track changes over time. And that aspect of monitoring has some important implications for how we develop monitoring programs. If we draw the parallel to traditional field crops agronomy work, what you might be answering here is the question of, is my potassium level increasing over time? So I've been applying the rate of potassium you've told me to. Has it changed the potassium test on my soil? So again, measurement is more focused on a single point in time, whereas monitoring is taking that longer term view of comparing measurements over time. And that cumulative effect over time has some important implications for how we handle monitoring data. So the convenient thing about monitoring for soil health is that a lot of the existing precision ag tools that most CCAs are using have direct import to monitoring soil health. So what we're looking at here is a soil management zone map. These are zones based on a USDA soil survey data. And this is one of the ways you could identify management zones within a field. So in this example, we're looking at several colors of management zones. Each of these would ostensibly have a specific fertility rate or maybe cropping rates associated with them. But in the context of this discussion, we're really going to be focusing on using these zones to measure soil health. So if we go to each of these locations denoted by the black points and pull a soil sample and compare the soil health indicators across that field, we notice that the zones from which we collect those samples have a large bearing on the value of that soil health indicator. So in the graph on the right here, we're looking at soil organic carbon concentrations taken from the blue and the green zones respectively. And you'll notice that the average value of that organic carbon is very different depending on which zone you're in. In the blue zone, it's around 1.25%. In the green zone, it's around 1.75%. So that's about a 0.5% difference depending on which zone in the field you're measuring from. And this gets back to the important part around measuring soil health, and that is that soil health and soil health indicators are site specific. By measuring the zones correctly in the field, we can get a better idea for how the soil health might be changing within a field. The green zone might require less inputs to increase the soil carbon concentrations than the blue zones. And these are really important services you can provide to clients by giving them an understanding of where the healthier or unhealthy soils in their field might lie. So just to recap, adjacent management zones can have up to a 0.5% difference in soil organic carbon. And sampling strategies for soil health that benefit from site-specific zone management can be really valuable services to provide to clientele. That leverage, let me reiterate this, the existing precision ag tools that you're probably already adopting and using. So we've talked about the importance of site-specific management for soils for a measurement perspective, but what about the case for monitoring, where we might be thinking about looking at changes in soil health over time? So we're going to sort of show some fictitious data just for illustrative purposes here. But let's say you have a client who wants to adopt cover crops. And they want to do that with the explicit purpose of increasing their soil organic carbon concentrations. So year zero being the sort of forethought and innovative CCAUR, you collect a soil sample at the gold point, with the goal of coming back in 5 years and taking another measurement. So 5 years passes, you collect the sample at the blue point, and now you've got values of soil organic carbon from before and after they implemented those cover crops. And we can plot the change in soil organic carbon concentrations over time. And sure enough, we see an increase in carbon concentrations due to the adoption of cover crops in this field. So we can observe roughly 0.5% increase in soil organic carbon over 5 years, with the conclusion being that your soil health is improving. Now, let's take that same sort of example, and instead of collecting those samples very close to each other, what if you just moved that point over by a couple hundred feet? Right? So now, instead of both points falling within the green management zone, one point is falling within the blue management zone. So our return sample at 5 years is actually in a different type of soil with different site-specific soil health targets. So if we graph these data, we might see a flat line going from our 0 year to our 5 year sample. So the gold sample to the brown sample shows no change in soil organic carbon. So we observe a 0% increase in soil organic carbon concentrations between the gold and brown points, with the conclusion being that there's no change in your soil health. Now, I kind of built this as a pretty easy and kind of cartoonish example, so hopefully you see what's coming here, and that really is that by changing the location of those samples, we've actually changed the value of our organic carbon concentration, and that the observed change in our second scenario, or lack of observed change rather, in our second scenario, is really what's driving that conclusion. So by keeping our monitoring samples in the same management zone, we can account for those site-specific soil health impacts and hopefully improve our understanding of monitoring those soil health changes. So key takeaway here is that due to site-specific variability in soil organic carbon concentrations, not changes in our actual soil health, we're seeing changes in our monitoring results. So the spatial variation from site-specific changes in soil health is really important when looking at these long-term monitoring goals. So if there's one takeaway from this discussion, it is really to use the precision tools you're already adopting for soil sampling and applying them to monitoring, because especially in monitoring situations where you're taking a multi-year view of changes in soil health, you want to be certain that those changes are due to temporal effects and not to inherent spatial variation within a field. So to recap our discussion, measuring and monitoring of soil health should leverage your existing precision soil sampling infrastructure. And the best way to do that is to take and adopt your existing sampling zones or zone-based soil sampling approaches to sampling soil health. The same way you're measuring zone-based samples for soil fertility, it's very likely you'll see strong benefits from adopting that same infrastructure for sampling soil health. And the important takeaway here is that particularly when we're thinking about monitoring or evaluating changes in soil health over time, that zone-based sampling is really important, because spatial variation can confound monitoring effects. We want to keep subsequent samples in any monitoring approach as close together as possible to mitigate potential spatial variation, confounding those long-term management results. So using existing precision soil sampling infrastructure is the best practice for monitoring soil health. And when monitoring, really be careful about selecting points time in and time out that are close to each other or at least within the same soil management zone to minimize the confounding effects of spatial variation. So we've talked a little bit in the last section about how to measure soil health, but now we're going to sort of tweak that a little bit and think about ways we could take those existing precision ag tools to measure soil health management. So why would we want to measure management practices? Well, one of those aspects might be to quantify the effectiveness of a practice, right? If you want to think about, I've been a farmer who's invested in cover crops and I want to know, say, how much cover crop biomass I'm getting for my seeds. Well, it might be important to quantify that so I know if I'm getting appropriate stand for that cover crop. We also might want to develop adaptive management scenarios to enhance crop response. So for example, if we have a lot of cover crop growth in a field, we might need to change our fertilizer rates to compensate for that additional cover crop biomass. And lastly, we might want to measure our management to develop records that can show a client has been implementing a service. So they adopt or enroll in a carbon marketplace, they might be asked to actually verify that they've been doing certain practices or not doing others. And this is where having a digital record or precision record of those practices can be really valuable. And this is a topic we'll talk about broadly. It's referred to as traceability. So this image is showing a cover crop field near my house in Indiana. And in this field, they planted a radish stand. This is early December. We hadn't really had a very harsh winter, and the radish was still growing quite well. But hopefully what you can see, even within this small field, is there's quite a bit of variation in the greenness of that radish stand. So we have portions of the field where we have lots of green, very strong radish stands, and then other areas in the field where that stand looks a little bit more anemic and it's doing a little bit less good of a job at being a cover crop. So one of the questions a client might want to ask is, okay, I have some variation in my cover crop. Is that impacting my cash crop? Or are there ways I can get a better cover crop stand across my field to get the most benefit from my investment in soil health management? So just to recap, we have some areas of high cover crop growth, some areas of low cover crop growth, and clients might be interested in quantifying the impacts of those variabilities. So questions clients might be interested in asking would be things like, how variable is my cover crop, or did I get good cover crop growth this year, right? All of these are questions we can start answering with precision agriculture and existing precision agricultural tools. So these are ways you can start providing additional services to clients once they've planted those cover crops or once they've adopted that soil health management practice more broadly. So if you think back to one of my first slides, I showed you a line graph that illustrated many of the existing practices done by precision ag dealers. And around 70% of respondents in that survey said that they were providing some sort of service based on satellite imagery. So what we're looking at here is a satellite image of a field growing cover crops in Nebraska. I can't take credit for this work. This was all done at the University of Nebraska-Lincoln. And these researchers were interested in ways you could take satellite imagery to assess cover crops. So they're looking at one field in both images. On the left image, we're looking at normal color imagery. So the greener areas are showing areas where there's more growth of the cover crops. And the researchers applied a pretty standard processing technique called the Normalized Difference Vegetation Index that highlights areas in the field with good or poor crop growth. In this case, they're looking at cover crops. So the image on the right, the NDVI image, greener areas are showing areas of higher cover crop growth or higher biomass. So this is a really easy way that you can take an existing tool vis-a-vis satellite imagery and use it to help provide clients some guidance to assess cover crop stands or actually quantify their soil health management. So lastly, I want to touch on the topic of traceability. So some of the emerging ecosystem surface marketplaces, these would be things like carbon exchanges, will require data showing management history. And this shouldn't be surprising, right? If anyone's dealt with organic certification, that's part of the hurdles you have to jump through to certify a field as organic. You have to show that it has certain management history, that it hasn't used unapproved fertilizers or amendments for a certain period of time in order to make a certified organic status. The same thing is going to be applicable for many soil carbon markets or potentially water markets if they start coming on the fold. So as we think about how to help your clients position themselves correctly to take advantage of these emerging marketplaces and maybe diversify their on-farm income, keeping a record of their management is really helpful and can streamline enrollment in these processes. The good thing about that is much of the data you're already collecting can be used for traceability. Think about things like machine data, right? Every time that tractor goes to the field, there's a good chance you have a GPS track of where it went. And if you can verify that you went into the field 3 or 4 fewer times than you did 5 years ago, now you have a record that you've minimized the number of passes you've gone through the field. That might be a tillage pass, that might be a herbicide application pass. Regardless, you have some of that data that's already there. You just need to bundle it in a way that markets it as traceability data of showing we've done this practice or we have avoided this practice. And lastly, like we showed in the previous slides, cover crop biomass can be used to verify whether or not crops were planted. So this is another easy piece of data you can start using to build out that traceability portfolio for your clients, to give them the data to be able to leverage these existing marketplaces and new revenue streams. So just to show that I'm not completely crazy about this, there is some indication from surveys of precision ag dealers that these are important things in emerging in the marketplaces. So if you look at the sort of red line around 2019, 2020, we see that 40 to 38% of respondents are doing some sort of traceability. And then that's just projected to increase to around 50% over the next several years. So this is an emerging place where you could really be competitive by providing this new service that can help your clients diversify their assets. So just to really briefly recap, we can use a lot of our existing precision agricultural tools to evaluate soil health practices. So we use the example of UAVs and satellite imagery to quantify cover crops, but there's tons of other ways we can use existing precision ag data to verify or build out a case for what the soil health practices might be. The key thing with that is that many of those tools can really provide direct value when thinking about making traceability arguments for ecosystem marketplaces. So data on machine operations or cover crop planting can help you and your clients build out a portfolio that helps them engage with those emerging ecosystem service marketplaces. So just to recap our talk from today, we've talked a little bit about ways you can adopt soil health and integrate soil health into your consulting business, with really an eye towards leveraging those existing precision agricultural tools and using them to provide services around soil health. We gave some examples of ways you can leverage your existing precision soil sampling infrastructure to monitor and measure soil health, really focusing on using precision soil sampling to minimize spatial variation and get a better idea of how soils are both changing in time and in space. We also talked about some of the ways that our existing precision ag tools can help assess soil health management, thinking about ways of using things like UAVs and satellite imagery to measure cover crop biomass, and then helping your clients adapt or alter their management to those spatial variations in cover crops. And lastly, we talked really briefly, but importantly, about how those precision ag data can be really useful in helping build the case for sustainability and helping provide traceability evidence for your clients to enroll in ecosystem service marketplaces. So hopefully this has given you a really brief overview and kind of gotten the gears moving in your heads about some of the ways you could take those existing precision ag tools and modify them to improve soil health and improve your practice around soil health. So before we go, I would love to acknowledge the support of our sponsor, the Walton Family Foundation. They've paid for these webinars to be developed, as well as providing the CEU credits free of charge on soils.org. So again, if you would like CEUs for this talk, there's a title slide that sort of talks you through how to do that and gives you the URL to follow to soils.org, where you can apply for CEUs for the content of this talk. Thank you for your time today. If you have any questions or want to just reach out for conversation around applications of precision ag and soil health, again, my name's Dr. Jason Ackerson. You can reach me at my email here at thesoilhealthinstitute.org, and feel free to comment if you have any questions. We'd be happy to address them. Thank you for your time.